Welcome everyone. Just gonna give everyone another minute or two because we're still getting some people rolling in. Right. So, hi everyone. Thanks for coming. Anonymous attendee. Yes, the meeting has started yet. Right. So, today's speakers, Alan of our Dallas office. We're going to be going over automated testing, as the slide implies. If anyone has any questions during the talk, feel free to post them at any time. I will let Alan know when it's, not disruptive to him. And yeah, with that, Alan, feel free to take it away.
All right. Thank you. Appreciate that. Welcome, everyone. I first just want to express my gratitude for you taking time out of your schedules to show up and spend some time with me today. I know you have lots of opportunities to go to different things, and I'm always humbled when people take time out to come hear what I have to say. I'll do my best to leave you with something of value that you can take away from this. So this is me, and these are ways that you can connect with me. If you do reach out to me on LinkedIn, it's helpful if you tell me where you know me from, that you participated in this conversation today. I'm less likely to decline your LinkedIn request if I know where you came from. I have recently started a blog. You can access that at agenthoover.substack.com. And we'll post these links in the chat at the end so that you can have them easily accessible to you. I have been with Improving about 5.5 years, and my primary role is as an agile quality coach, B2D coach. I love to help organizations come into organizations and help them think about how to build better quality processes, how to cultivate a culture of quality. And I'm also an automation developer. I've been doing test automation for about 15 years now. And so as the talk today obviously is going to be focused around test automation, I'm going to be drawing upon that experience to kind of share some of the things that I've learned over the years. I should warn you that if you have attended other introduction to automation talks, what I'm presenting today may not be what you're expecting. Even if you've attended some of my talks in the past where I talked about automation, this may not be what you're expecting. My thinking has evolved and changes as I have more experience with automation and as my knowledge of the craft of testing grows. So hopefully, though, I can give you some good food for thought today about test automation and how it fits into the context of testing. So here's kind of a high-level overview of the ground we're going to cover. We're going to talk about what is testing, and then we're going to talk about what is automation. So you'll notice in my title there, I've kind of put a strike through the word testing and I've replaced it with checking. So we'll talk about why I did that and why I think that's important to make that distinction. I'll talk about ways that automation can be useful in testing. I'll talk about different types of automation that we can use in testing. And then I will leave you with a couple of examples of how you can begin to integrate automation into your process. So before we talk about automation, it's important to first frame the discussion by talking about testing. That's because what we do when we test is not the same thing that happens when automated test cases run. And when we conflate those two things, we will inevitably diminish the depth of our testing. And as a consequence, the quality of our product will suffer. So I want to start by talking first about what is testing before moving on to talking about the role that automation plays in our testing. And I'll start by just giving you a definition. And this comes from James Bach and Michael Bolton, who are kind of key thought leaders and developers of the rapid software testing approach and context-driven testing. And again, we'll give you these two links in the chat so that you can do a deeper dive into these things on your own if you want to kind of read more about how they arrived at this definition, because it's very carefully thought out and crafted. But testing is, first of all, a process of evaluating a product. Now, notice it doesn't say the product, because there are many products and artifacts that are part of the process of delivering software solutions to some problem. There are ideas that need to be tested. There are descriptions of the solution of a product, the requirement documents that can be tested. There are help documents that we provide to our end users that make claims about our product that can be tested. And there is, of course, the software itself, which is a product that has to be tested. I just wrote a blog post on a concept called prospective testing, which highlights a collection of testing activities that happen before any code is written on products that are part of the testing process or outputs of the testing process that are not necessarily the product itself. So it is a process. It's not a one-time thing. It's not something we do once. It is something we do throughout the process of developing software. And it's a process of evaluating a product by learning about it through exploration and experimentation. So we review the product and ideas and descriptions of it. We look for significant and relevant inconsistencies between the descriptions of the product and how it actually works. We experiment with the product to find out how it might be having problems, which, by the way, is not breaking software. Like testers talk about, breaking the software. We don't break the software. The software is broken. We simply discover how it's broken, and we shed a light on that. And we do that through exploring and experimenting on the product, systematically examining any aspect of the product with the goal of preventing surprises. Developers have an unwarranted optimism in the quality of their code and that it works perfectly. And as testers, we are fundamentally pessimistic about the product. And we have a belief, a faith that there are problems in the software. And so we are bug hunters, pressing into that belief with every available tool that we have, trying to discover where the product fails to meet the value that it needs to deliver to the users. And so some of the things that we have to do in order to explore and experiment is we question, we study, we model the software, we make observations about the software, we draw inferences from our observations, and then we do output checking. And I've bolded output checking here because that is really where what we typically think of as test automation can be helpful. When we automate something, we are not automating testing, because testing is a human activity. What we are doing is we are automating checking. We are checking some specific output of a specific, that results from some specific actions. Excuse me. So by defining testing this way, then scripting or automation becomes a tool that we use to help us in the process of testing. But it cannot replace testing. It is not testing. And we need to make sure we keep that clear in our mind as we talk about how to apply automation to the process of testing. And this is important because the dominant view of test automation today is kind of the idea that we're going to automate testing by automating the user. But the problem is we can't automate users. We can automate some actions that a user performs, but users do so much more than that. When I come to an application and I'm interacting, let's just say a form on a web page, in a blink of an eye as a human being, I can make 1,000 judgments about the software. I can evaluate things about how it makes me feel, or I might have tacit feelings about it that I don't really realize I'm having because it's ugly, or because the form fields don't line up and it gives me a bad sense or a bad feeling. I can observe things about how the form behaves, and I might do it differently every time. I might, in one case, come in and use my mouse to click on a field, type in some stuff, or I might use a tab key to navigate through the fields of the form. So as users, we bring so much more to our interaction with the software that we simply cannot automate. And so we need to realize when we talk about test automation, we're not replacing users. We can never replace users. We can never replace testing as a craft. Now, one of the things a tester does is we check outputs. I will do some things and then I will validate certain outcomes of those things, expecting certain results. That's what we call checking. We are checking results. And checking can be automated, but we do so much more than just check output. And when we do automate output checking, it's interesting, it's valuable, but tools can do so much more for us than just check output. So contemplate this map for a second. It's kind of a weird picture maybe for the words that are on the slide, but I have it here for a reason. If this map represents the surface area of your product, then we as testers are wanting to explore this space to illuminate, to bring light to it, to understand it. We want to find where the dragons are on this map. Where are the chasms that we might fall into? Where are the caves where bears might be living? We want to travel the roads, and we want to look for obstacles that have fallen across those roads. We want to evaluate the maps that we do have, the models of the software that we have, the claims about our software that we have, and see, do they match up with the reality of the landscape? We want to test our GPS and see, is it calibrated correctly so that it's pointing us in the right directions? We want to evaluate, we have two cities and they want to connect themselves with a railway line. So they're starting at different ends and they're building this railway. We want to see how well did they connect in the middle. And we discover, well, this one used narrow gauge rail. This one used large gauge rail or standard gauge. Can't say gauge rail. It's kind of a hard set of words. But they use different gauges. And so when they meet in the middle, even though they arrived at the same location, trains cannot successfully travel that route because the protocols don't match up. And as we explore this space, we are journaling, we are mapping out the new territories, we are taking pictures, we are documenting problems that we see. And as we do that, we bring light to some parts of this product. Now, in highly trafficked areas of high value, where lots of people live, where lots of people interact with our software, or maybe in areas of particular danger where we know there's a habit of marauding bears coming into the village. There's this part of this code where lots of bugs tend to pop up when we make changes. We might want to put some permanent lights in place to illumine some specific things about that area of the map. And this is what automation can do for us. One of the things that automation can do for us. But automation is not like a big floodlight at a football stadium. That would be more like what we humans do when we look at a piece of software with our brains. We can shine a huge light that covers a lot of things very quickly. But with automation, it's more like these small solar lights. Like I have a flower bed out here on the edge of my yard that has some big rocks around it. And my wife is concerned that somebody was going to trip over those rocks in the dark. So she bought some little solar powered lights to put along the edge of that flower bed to illumine those rocks, to illumine that danger. And so that's what automated checking is, right? They're tiny little lights that shine light on a very specific thing in the map of our software. And those lights are all, hopefully, they're all wired up wirelessly to some information radiator that can tell us very quickly when something unexpected comes into that light. And so we create 1,000 of these little lights and we place them all over our map in important and valuable places. And we hook them up to information radiators to give us feedback when something changes unexpectedly about that area. Now, that automated check can't give us a judgment about whether that change was good or bad. It can only alert us to the fact that something has changed. Then we as testers have to go evaluate that change and make judgments about whether it was good or bad. So the main thing that I'm trying to communicate here is that automation is not testing. Automation is a tool that we use in testing to check some specific outputs under specific conditions. But it can do nothing more than illuminate that small area that we've pointed it at. So if we go down the path that so many organizations are going down now of reducing testing down to nothing more than the sum of their automated checks, we need to realize that we're leaving vast parts of our product unillumined. And we will fail to find dragons and bears that will attack our poor, unsuspecting customers when we unleash that product on the world. Automation is not testing, it is checking. Automation is not experimenting, it is demonstrating something that has already been shown to be true in the past. When you're in high school and you go to physics or chemistry class, and your professor or your teacher showed you an experiment, that's kind of a misapplication of the word experiment. They're not really doing an experiment because they're not learning anything new about the nature of physics or chemistry. What they're doing is demonstrating to you something that somebody has already discovered and proven. And so it is a demonstration. And that's what automated testing is, or automated checking, we should say. So James and Michael go on to say that checking is the process of making evaluation by algorithmic decision rules to specific observations of a product. So if you don't take anything else away from this conversation today, I hope you get this concept that automated checking is not testing, and that it cannot replace true testing and deep testing, but it can be a valuable tool that we leverage to help us in that process. So let's do a little thought experiment. You guys can use the chat to just give me a quick response here. How many of you would be able to knock over a redwood with your hands alone? Anybody feel like they can do that? We don't have a quick way to get thumbs up on this, so I'm going to assume we all agree that that's not something we could accomplish. So if I told you the tree had to come down, what would you need to do it? Like, give me some responses in the chat. Anyone? Okay, you got a chainsaw, right? What else? Any other things you might need? Chat is disabled. Oh, well, that's unfortunate. Okay, well, then let's just go on. You guys kind of know where I'm going with this. We need tools, right? We have to have something to help us do something that we could not do without them. And we can use automation in the same way. It's not just about checking specific things. That's one way that we can use automation. We can also use automation to do things that we otherwise would not be able to do. So let's talk about what some of those things might be. So automation is a tool that to extend human capabilities and do things we can't or otherwise would not want to do. We can create 1,000 tiny checks. So as we're building software and introducing additional complexity to our software, the number of things that we need to check over and over again to ensure that we haven't inadvertently introduced a regression grows to the point where we are not capable of doing that without the help of tools. And so we create 1,000 tiny checks. We do that, and that helps us to partially automate some of our test coverage. We might use risk analysis or value analysis to determine what we want to automate, what checks we should automate. But we can do other things. We can use tools to help us generate test data. In my last client, I worked with a team of guys and gals that were focused specifically on creating an API to allow testers to very quickly configure kind of the core data object in the system. And we took something that would take a tester normally 15 or 20 minutes to kind of go through and configure, and we used tools to allow them to do that in a matter of 20 or 30 seconds. And not only could testers use that to set up data for things that they were doing without other tools, but we could also tie that into our automation and enable automated checking to run quicker because we could set up data very fast. We could also use that to generate tests. So in another example, I worked at a company where they created a query engine that allowed users to define their query filters or aggregation categories and slice and dice the data in a number of different ways. And the number of combinations and permutations of potential options that the user could choose was astronomical. It was in the hundreds of thousands. And most of the defects that we saw getting into production related to some combination of those things that failed to compile. It failed to create valid SQL. And so I worked with one of the developers, and we created a piece of code that read the metadata out of the database that was used to present to the user the options that they could use to create queries. And we iterated through that data, that metadata, and used it to generate test cases using combinatorial, regression to recursion to create thousands of test cases with different combinations of these potential options. We ended up with about 180,000 test cases that were being generated. Now, we weren't concerned with that particular set of test cases that were being generated about the actual data being returned. We had other tests to examine that. What we cared about was just that the query would compile successfully. And so we could then run that 180,000 permutations exercise it in about an hour. Super powerful tool that was not checking a lot of things, but it was generating these test cases for us and giving us some valuable feedback on whether the code that was being generated from these combinations was valid code. We can automate oracles. And what I mean by an oracle is anything we use to recognize a problem during our testing. Generally, we think of those as asserts. When you have an assert in a test, that is one type of an oracle. But we might create something to parse a log file and collect certain pieces of information out of that log file over time. And we can then use that to evaluate the outcome of some particular testing process, or to explore the output of some particular testing process. Maybe we need to capture the performance of our software at milliseconds level. This is not something a human can do. We need tools to help us do that. So we capture how long it takes on the level of, on the granularity of milliseconds, and use that to examine where the bottlenecks in our code are. We can use automation to ramp up load on our systems so that we can see how it responds to stress and how it performs under high loads. These are different ways that we can apply tools to help us in the process of testing that go beyond just some action and validating the output of that action. Okay, so I'm sure you all have heard of the test automation pyramid. At least heard of it if not having had somebody explain it in depth to you. I'm not going to talk about the pyramid today. Actually, it's not even a pyramid, it's a triangle. I don't know why we call it a pyramid, it's a triangle. If you want to know more about it, just go search for test automation pyramid. You can get dozens of hits immediately. I'm going to introduce you to a different model that is, I think, a better model for kind of presenting the same concepts that a test pyramid tries to present, but without glossing over some of the complexities that's actually involved here. And this is James Bach's, sorry, got ahead of myself. This is James Bach's round earth heuristic of test strategy. And it's not just about automation, it's about testing in general. But I'm not going to explain this model to you in depth. I'll give you the link to his website and a video that he did on this so that you can kind of get his own words on this model. I just want to use this as a framework for talking about how we can apply automation, or different ways that we can apply automation to our testing. And so to begin with, one of the most valuable places where we can apply automated checking to our testing process is at the unit level. So simply speaking, this is an earth, right? It's a sphere. And at the core of that sphere is your platform, your application framework, and the environment, your OS, things that we don't generally have immediate control over. And then built on top of that, we have the code. And that code is a collection of units of things that are responsible for specific functions that the code provides for us. And we can test those functions individually in isolation. We call this unit testing. And this is a great place to begin automating checks. And in fact, I'm a big proponent of test-driven development, where we write an automated check to describe some outcome of a specific behavior or a specific action. And we have that failing test then to help guide the design of our code and help us to know when we've achieved that particular outcome with our code. Moving up from the units, then, we combine units together and we end up with subsystems or services. And we usually have multiple services that interact with each other and interface with each other. So they are interacting subsystems and services. And this is where things like API testing and contract-based testing come into play. This is where we can look at these two different railroad tracks coming from different directions and ask questions about, do they meet the contract that has to be adhered to in order for them to communicate successfully? We can create an oracle that is a contract that describes both the consumer and provider side of that contract. And we can give that oracle to both sides, both the consumer and the provider, and say, here's the contract of behaviors that you need to expect from this interaction between the two. And we can automate that to provide us a continued safety net around the contract between those services. But things get more complicated at this level because now we're introducing data into the system. And whenever you introduce data, now you have to think about test data management, making sure that your individual test automated checks are not inadvertently influencing other checks because they're corrupting or modifying or mutating data that other checks belong to. And that creates complexity. It makes tests a little bit harder to write effectively. So we introduce tools at this point that are more than just checking tools. They are tools to help us with test data management. There are tools to help us with log aggregation and parsing. There are tools to help us with monitors and alerts. We want to provide testers access to deep product, to the deep product through the use of good tools. But notice here at the GUI layer, it's generally advised to avoid automating. Why is that? And this is important because most companies, when they start into automation, this is where they start. And you have a lot of tool vendors out there building big, complex tool systems. And they're trying to sell you on the idea that you take these tools, you can automate the users. And that always seems to start at the UI level. And yet in this model and in the test pyramid, the emphasis is on pushing your automated checking down into the lower layers and reserving automation at the surface level for a handful of very critical and very important automated checks. And that's because there are more moving parts required at this level. And when you have more moving parts, the more likely it is that some change introduced into the system will have unintended consequences for tests at the UI layer. They may break more than other types of tests because they catch more regressions because they're susceptible to unintended changes. Also, when tests fail at the UI layer, they're a lot harder to track down. You might have a defect that's introduced at an API layer that impacts 30 or 40 of your UI automated tests. And as you start triaging those tests, it might take you a few hours to figure out what the initial actual root cause of those failures were. And actually that takes you a few hours to figure out what the failure is for that first test. You still have to evaluate the other 24 and not just assume, oh, well, that's the reason all these tests failed. There could be other reasons why those other tests failed. And so evaluating failures at that level can often be very time consuming. Now, there are times when automating at the UI layer is appropriate, but we shouldn't, that's not where we should start. And that's not where we should put the bulk of our investment with automated checking. Having said that, I do want to make a point that we should not neglect the surface of the product. High-level tests at the surface of the product have special power because bugs that are found at that layer are more likely to be visible to your users. It's more likely to generate calls into your help center. It's more likely to cause your users frustration. And also because there are more and bigger dependencies that are required in order for software to function at that level, that means they are more sensitive to buggy changes. It's also easier to do large sequencing or data flow testing or timing, testing that requires timing involved at that level. But all of those things, while they have special power, also present special challenges to automated checking. So just be aware that while it's really important to keep a focus on the surface, it's often not advisable to try to automate a lot of things at that layer. Okay, so we've talked about automated checking is not testing. I hope I've made that case. We've talked about what automation can do for us beyond just checking. So now I want to kind of finish up by talking about ways in which we can begin to integrate automation into our development context. And I'm going to present you two different tracks or two different approaches to integrating automation. There may be other ways. These are just ways that I have been successful with my clients at starting to integrate automation into the process. And so in this first track, if you will, it's kind of applicable to an agile environment, maybe a Scrum environment where you're doing iterative development and you're trying to leverage automation to help you with your testing in an iterative fashion. And so in this context, we start with a user story. And we have refinement and sprint planning, where we explore that user story and we start to define what our acceptance criteria is, what our requirements are for that story. And there are testing activities that happen here. So you can see the yellow, anything inside the yellow is part of what we do as testing. Anything inside the blue is kind of what we do as part of development. And so as part of testing, this kind of pre-development stage, we can use things like example mapping to define what our test plan is going to be. So testing and planning for automated checks starts with your backlog refinement and carries into your sprint planning. This is where we think about how we as a team are going to test the user story. What is our plan? And a plan is the intersection of our strategy, which is the way tests will be designed and executed, and the logistics that we need in order to execute that strategy. That is the resources, the tools, the data, the environments that we'll need to execute that strategy. And so we define this set of acceptance criteria, and we begin to formulate, which bleeds over now. We're starting to move into the development phase. We begin to formulate some of those examples, some of those scenarios into scripts that we can automate. Now, if you've had exposure to BDD, you might recognize this as kind of the first phase of behavior-driven development, the second phase of behavior-driven development, which is formulation. Discovery being what we talked about as the first part, formulation being the second part. But even if you're not doing BDD, right, you still have to formulate the specific scenarios you want to automate into a script. Like, here are the steps that we're going to take. Here are the element locators we're going to need. Here are the things we're going to check. And then as we go into the development process in the sprint, your automation engineers can begin to automate that scenario. They can script it out. They can put it into the test tool. They can stub out things where the development is not done yet as placeholders while the developer is working on the code. And we can give that stubbed out test or that failing test at high level, whether it's API or UI, to a developer. And a developer can then start using test-driven development to write unit level checks to guide the design of their code, to guide their public-facing APIs in their code. And they'll write a failing unit test. They will write enough code to make that test pass, that check pass. Then they will step back and they can refactor their code and refactor their test to clean it up, make it nice and good, think about their design. And then they move on and they repeat that process over and over again until they have enough code to make that automated scenario pass. And then they go back and they look at what is the next formulated scenario that we need to develop and make pass. And this iterative process can happen in collaboration with your automation engineers, with your testers. As we develop code, we might learn new things that we want to add into our automation, that we might want to add into our automated checking. And then once we're done and we feel like we've got the code finished, we feel like it's delivering the value that it's supposed to deliver, we have a collection of unit and API and maybe a handful of UI level automation in place to provide us some of our test coverage, then we continue to test. We put that code into an integrated environment. We continue to explore. We continue to experiment. We continue to learn about that particular feature, about how it integrates with the rest of our product. We might discover problems by doing that, and those problems become a feedback loop into our automated checking. We can add additional automated checks for that defect that we found. Okay, and then when the code is delivered, and at this point, right, we keep doing that until we believe there are no problems or omissions in the feature that would threaten its value to our clients in any material way. And any problems we find, have fed back into that automated loop at the appropriate level. And now we can hand that to our product owner or product manager and say, okay, this is ready for you. you can now go to your acceptance testing. You can go validate that we've done the job that we set out to do. And then after we deploy this into production, guess what? We can keep testing. We can leverage tools to monitor how the product is behaving with our users, then monitor the logs. We can set up alerting so that we know before anyone else does if something starts to go horribly wrong. Okay, so that's the first track. And that's a very powerful way to leverage automation to support the testing that you do on your product. The second way, their second track that you can follow to help leverage automation and tools for your testing is to have toolsmiths. And toolsmiths are developers whose sole purpose is to help build tools to facilitate your testers. They're the ones that are building the augmentations for your hybrid human and automated testers. We've talked about test data generators. We've talked about test case generators. Another example of this is for one of my clients, they built a product that was a spam filter. And they needed a way to quickly generate a lot of spam email into an SMTP mailbox. And they had a tool to do this, but it was kind of cumbersome and it was kind of slow. And you kind of had to do it one at a time. And for automated purposes, we didn't have a way to leverage that tool to hook into our automation. So I worked with them to develop an API, a command line tool that will allow them to define some characteristics of the type of spam email they wanted to generate, and quickly generate a whole collection of spam and send it off into this mailbox that they could then use in their testing, whether it was automated checking or not. They could still leverage this tool to help them. So I was functioning as a toolsmith in that capacity to extend the capabilities of my testers. Toolsmiths can be those people that are building your frameworks and abstraction layers in your testing frameworks to enable non-technical testers to contribute to automated checking. So maybe we use keyword-driven frameworks that give users drop-downs to select keywords and build scenarios. Or maybe it's a BDD situation where non-technical testers can write feature files, but we're providing the glue code and the automation to back those feature files. And so you can partner with non-technical people to help facilitate their ability to contribute to automated checking. Or you might be providing things like service virtualization and mocking to create isolation from third-party dependencies that you don't control so that your automation can be more deterministic and stable. And a lot of times I've seen toolsmiths has separate teams that have their own backlog, and they are servicing the testing community in the organization to help build their capabilities and extend the organization's testing capabilities. Okay, so we're down to about 12 minutes. Let me just kind of review what we've covered, and then give you guys a chance to ask any questions or any dialogue that you want to have about some of the things that we've covered today. So first thing, automation is not testing, but it is a tool that we use in the process of testing. We use tools to extend the ability of testers. It's not just about automated checking, but there are other ways that we can leverage tools to extend testers and testing. We can apply automated checking at different layers of our application, not just at the UI, particularly at the unit and API levels. Tools can be very valuable to help us with automation. We can integrate automated checking directly into our development process. I often encourage teams to think about how they explicitly identify in their definition of done how they're going to integrate automation. What I don't find terribly successful is having automated testing, building your automated scenarios as a separate user story from the code that you're building. or have it as a separate team or outsourced to some other organization even. I don't find that to ever be successful because your team is the one that is making changes that are causing code that is causing tests to fail, whether it's introducing defects or just change that requires tests to be updated. It is the team that is making those changes. And if you don't have a process in place to update those tests as those changes are being introduced, you will always have tests that are failing for the wrong reasons, and they will not be tested, they will not be trusted, and they will lose their value over time. So integrate those into your process. Think about how you use that as part of your definition of done. And then consider having toolsmiths who are really passionate about helping testers be more effective by providing different types of tools. Very well. So that's my introduction to automation. I hope maybe I've stretched your thinking about automation in some ways. And so curious, what questions do you have or what comments do you have about this?
One that I had myself is that you went over the round earth heuristic of test strategy, that it would imply that there's a flat earth heuristic.
Not that I'm aware of. I feel like you might drop off the edge of that heuristic, though.
So I actually
I mean,
had
we kind of laugh about.
so I
Sure,
actually
go
had
ahead.
a question slash maybe comment about the toolsmiths. I was wondering what kinds of tools you've found useful that people have developed internally.
Well, I talked about the spam generator. That's one tool that could come from a toolsmith. There are other tools that are available even on the internet. So there's all pairs is a combinatorial testing or combinatorial generator that will take a set of inputs and create all the different combinations that data could supply. Toolsmiths, I've seen them used to, well, I talked about the test data management API that I worked with one client where we created an API and we put a UI on top of that API to facilitate setting up and creating test data quickly. They might help in integrating automated checks into your build pipeline. So creating reporting tools or so that's another thing that I did for one client is we had BDD integrated across about 50 or 60 different repos, and each of those repos was reporting individually their BDD, but we didn't have a holistic view of all of that testing. And so I wrote a integration script to aggregate the results from across all those and present a unified report. That's another tool that gives visibility to information that we had, but that was hard to get access to. So those are some examples of other things that toolsmiths can do. So I see the question from Enrique. The presentation was amazing. Thank you. One question: in my company, we do not have the toolsmith. Which would you say would be a good set of tools pre-existent to automate other things, not just at the GUI? So, I mean, we have API level tools like Postman, which can be used to help explore APIs, or Rest Assured, which can be integrated into automation better than Postman. Postman is good for exploring manually kind of what's going on with APIs. I struggle with it as an automation tool. I think there are better options for that. Bud, do you have some feedback on that?
Yeah, Postman's a good one. Selenium is a good generalized tool. that will help automation. Those are the two I can think of off the top of my head.
Yeah, so from an automation standpoint, tools like Playwright, tools like Cypress are becoming popular, and those are generally UI-facing tools. But both of those tools have capabilities at the API layer as well. Both of those tools have mocking capabilities so that you can create isolation from third-party dependencies, things which Selenium doesn't do. So those are some things that come to mind immediately. I think I could come up with more if I had a chance to think about it a little bit. So good question. Thank you, Enrique. Any other questions? Any other comments?
Yeah, we just got
So I see this question here. You said automation is like a guiding light that will find all the problems in your code that exist already. Like a piece of art, a product can always be further perfected. How do you differ edge cases from critical issues? I'm not sure I completely understand the heart of your question. Edge cases are definitely important to explore, and even capture in automated checking. Like I do a lot of times when I'm working with teams, I'll ask them not just what is the happy path case here that we need to automate, but what are ways that this can fail, or what are boundaries that we need to explore? What are edge cases that we need to explore? And then we will think about which of those are valuable for automation. I'm not sure that answers your question. If not, you can elaborate a little bit. Maybe I'll try to fill out a little bit more. Yes, Jonathan, that's a very important thing. Thank you for bringing that up. He said, I've said automation is not testing. Often as developers, we focus too much on things like coverage and forget the why. Never forget the why. Yeah, absolutely. Particularly when I'm working with user stories, user stories are often formulated in the kind of the three phase as I want to so that, and that so that piece is the value of why this is important. And I like teams to invert that to start with in order to achieve some value and to talk about what that value is before we talk about what it is we're trying to do and who's going to do it. Really getting to the heart of why is important. And automated checks can never really tell you that. You have to think critically about that. Cool. Anything else? All right, so I'm going to ask you one last question, and this is just for my benefit. If you wouldn't mind, take 15 or 20 seconds and think about what was the most valuable thing you got out of the presentation today, and just drop a quick comment into the chat for me. This is really helpful to me as I build presentations, as I give talks like this, to hear what people took away from it, what was valuable to them. So if you don't mind, just what was the most important thing or the most valuable thing that you got out of this conversation? And as you do that, our presentation is done today. I thank you for taking time out and coming to hear what I have to say, and hopefully there was something of value for here for you today. So thank you and enjoy the rest of your day.